Hello, good evening to all of you. I hope all of you are doing well. So in today's class, we are going to discuss default argument. Now, default argument is a value provided in the function declaration that is automatically assigned by the compiler if the caller of the function does not provide any value to the argument. Okay. Now, let us consider a function declaration. So let us consider a declaration as integer sum, integer a, integer b, integer c, where c is equals to 5. Okay, right? So now here a and b are normal variable and c is a default variable that has been assigned with value 5. Now, what is the use of default argument is that in situation where the calling function does not provide a value for the default argument, what it will do, it will assign the default value, that is 5, in order to perform operations in that particular function, right? Okay, so here the very purpose of default argument is to take the default value in situation if the value for that argument is not provided. Now, default arguments are definitely not constants because default arguments can be subjected to change if the caller function provides a value for it. So if a caller function provides a value to the default argument, then the old value will be overwritten by the new value that was provided by the calling function. So default, you see, this is what this particular point is trying to infer to. So default arguments are different from the constant argument, as constant arguments cannot be changed, whereas default argument can be overwritten if required. Now, default arguments are overwritten when the calling function provides a value to them. So this is a very important statement that you need to remember. So whenever a new value is provided to the default argument by the calling function, then the new value will override the previous value. Now, you need to all one important thing about function call that you need to remember is, so whenever a function call is made, the values from the calling function are copied to the called function from left to right. So values are copied from left to right from the calling function to the called function. Now, once a default value is provided to a argument, right? Again, once a default value is provided to an argument in a function definition, once a default value is provided to an argument in the function definition, then all the subsequent variables that are there placed after the default argument will be considered as a default argument. So this is one of the important characteristics of default argument. So if a default argument is placed in a function declaration, then all the variables that are placed after that particular declaration, after that variable, will be considered as default argument. So for example, if you have a declaration like integer sum, int x is equals to 0, and subsequently you have variables y, z, and w. So y, z, and w will be considered as default argument. Now here, just see, we have a very simple program. Here I have declared a function by the name sum that takes in 4 integer values, out of which 2 are simple variable, and the latter 2, that is w and z and w, are default arguments. So z is assigned with 0, w is assigned with 0. Now you can have any value for default argument, so it's not necessary that you need to have only 0. You can have any integer value, right? So integer x, integer y, integer z is equals to 0, integer w equals to 0. So now whenever a function sum will be called, if the value of z and w are not provided, then it will take the default value 0 and 0 for z and w. So let us consider the three statements that are there, right? So in the first instance, so what I've done is I have called function sum by providing 2 integer values, 10 and 15. Now 10 will be copied to x, 15 will be copied to y, and since z and w, values for z and w are not provided, so it will take the default value, that is 0 for z and 0 for w. So this particular function will return 25 as sum of 10, 15, 0 and 0. Now in the second instance, what I've done is I've provided 10, 15 and 25. Now 10 will be assigned to x and 15 will be assigned to y, where z will be assigned with 25. So the previous value of z, that is 0, will be now overwritten by 25, where w will remain as 0, right? So that it will return a value 50, right? Now in the third instance, what I've done is I've provided value for x, y, z and w as well. So x is 10, y is 15, z is 25, and w is 30. So altogether it will return the sum as 80. So just see, this is the way how the default argument basically works. So now let us consider some of the declarations. Let us see some of these declarations and prove it whether it's legal or illegal, right? Okay. So the first one, in the first case, x is assigned with the default value 0. So since x is assigned with default value 0, by the very property of the default argument, all the variables that are placed after x should be a default argument. So since y, z, and w are not assigned with any default value, so this particular declaration is wrong. In the second instance, x is provided with 0, y is not provided with any value, z is provided with 0, and w is not provided with any value. So since x is already assigned with 0, y, z, and w will be considered as default arguments. So since there are no default values to the three variables, so this particular syntax is also illegal. In the third case, x is there, y is there, z is assigned with value 0, and w is assigned with value 20. So here, since the first default argument is z, which is assigned with 0, and after that w is also assigned with 20. So this is a very legal declaration statement, right? Okay. Now in the fourth case, x is not assigned with any value, but y, z, and w is assigned with 12, 0, and 20 respectively. So this is again a legal declaration statement. Now in this fifth case, all the variables that are there, x, y, z, and w, are assigned with some default value. So this is also a legal statement. So this these are some of the examples of the legal and illegal declaration using default argument. Now, constant arguments. So what we can have is we can also have arguments provided to the functions that are constant. So here, just see, we have cited a very simple example: constant character asterisk ptr. So here, ptr is a pointer that's capable of pointing to a character array that is of type constant, right? Okay. So this is the way how what we can do is we can provide a constant argument to a particular function. Now let us move on to a very special concept in case of C++, or one of the important concepts in case of C++, that's called as function overloading. Now function overloading is a mechanism using which what we can do is we can have multiple instances of same function. We can have multiple instances of same function that's capable of performing different operations based on the number or type of parameters that are provided to it, right? So what we can have is we can have multiple instances same function. So for example, I can have multiple instances of add function that's capable of forming addition of integer values or floating point values. So the way how the difference is made is in the number and the type of the parameters that are passed to the function. So function overloading can be considered as an example of polymorphism. It's an example of static polymorphism, or static binding in case of C++. So function overloading is a feature in C++ where two or more function can have the same name but different parameters. So just see here, I have six instances of function add. Just see, there are six instances of function add, or six functions that has the same name add. But what does it vary in is it varies in the number and the type of the parameters that are provided to that particular function. So the first function takes in two integer parameter, then the second function takes in three integer parameter, the third function takes in four integer parameter, the fourth one takes in two double parameters, fifth one takes in three double parameters, and sixth one takes in four double parameters, right? And the return type of the functions are also different. So here what I have is I have multiple instances of function add with different parameter list and different return type. Now just see here, what I've done is I have separately defined the different functions. So here, this is the definition for the function that takes in two integer parameter. This is the definition for function that takes in three integer parameter. This is the definition for function that takes in four integer parameter, and subsequently the other functions are also defined. So whenever we call a particular function, so what it will do, it will check the number and the type of parameters that are being passed. So here in the first instance, I'm passing two integer value, so it will call the function that takes in two integer values, right? Okay, so likewise in the second case, I'm passing three integer values, so it will call a function that takes in three integer values. So in the third case, I've called a function add that takes in four integer values, so it will necessarily call the function that adds four integer values. So depending upon the number and the type of parameter, the appropriate function will be called and the operation will be performed. Now here, one of the important thing that you may see is that I could have used floating point instead of double. Okay, right? I could have used floating point instead of double here as well. So here, in one of the typical problem with C++, we will come to that as well, is type conversion. So any floating point constants that you provide will be automatically type converted into double. Okay, so that's the reason why what I've done is I have provided the argument as double, because floating point constants are automatically type converted into double, right? Any floating point constant that you provide. So instead of that, what you can do is you can declare a variable of type float and provide that variable here. So then what you can have is we can have the argument as float in the declaration statement. So this is the way how function overloading works. So depending upon the number and the type of parameter, the appropriate function will be invoked and the operation will be performed. Now, we have listed few of the instances where what we cannot do is we cannot overload functions. Okay, so I'll discuss few of this, right? Again, so the first one is a function declaration that differs only in the return type. So this is an instance where what we cannot do is we cannot overload a function if the return type differs. So here there are two instances of this. One returns integer and the other one returns a character, right? The second instance is that in situation where there are static member functions declaration. So when the functions are declared as static, right? Okay, so then also what we cannot do is we cannot use overloading. So what we can do is you can just go through the various instances in during which what we cannot do is we cannot use overloading. So that is for you to just go through, because we'll be discussing this whenever we will be discussing polymorphism. So in today's class, what we have learned about is we have learned about what is a default argument, what is the use of the default argument, and what happens when the values are not provided to default argument. We have try to understand default argument with the help of an example, and then we have been through some of the valid and the invalid declaration for default argument. Then we have moved on to how to pass constant as arguments. Then we have discussed in brief about function overloading, and we have tried to understand function overloading with the help of an example, right? And we have also been through some of the instances where functions cannot be overloaded, and portion of that is left to you to go through, because we'll be discussing this in detail in the upcoming classes. Thank you very much and good evening.